All right. Trig Quiz 3 preview, where we heard that before. Inside joke for people here. So all we're looking at in this first graph basically is an amplitude change. Now, even though that tells me that my radian measures of my angles are going to change, I don't have any shifts going on. I don't have any period changes going on. So I know that I'm going to be dealing with 0, pi over 2, pi, 3 pi over 2, and 2 pi. And if at this point you're looking at me and going, how do you know that? Uh-oh. Okay. So when we get here, I also notice, again with this -4, since we're going to be doing some multiplying here, I'm going to be at 4 and -4. Since I have no vertical shift, my center line is still at 0. It's not none, okay? Because if I wanted to actually put it in, it would just literally be here on my x-axis. My amplitude, another place where a little bit of caution needs to be brought in. Amplitude is a distance. Distances are positive. Yes, my A value is -4, it's true. But my amplitude itself is 4 because I'm shifting up and down that 4 value. My period we just got done saying is 2 pi. If we would have had a value in front of the x, we'd divide by that, 2 pi divided by b. And this time, we have no phase shifts. Okay, we have no left and right shifts. So, the other thing I can do that could possibly mess me up on this is forget where my cosine graph starts. Cosine normally starts at 1. It goes to 0, -1, 0, and back up to 1. And doing a little marking like that doesn't hurt anything. Because now all I have to do is take it and multiply it times my A value. So -4 times 1 would be -4. 0 times -4 is 0. -1 times -4 is +4. 0 times -4 is 0. And 1 times -4 is -4. So basically, we get an upside down cosine graph. When it says make sure to label 5 ordered pairs, to me, the 5 ordered pairs are labeled. Because I can see where your values are here, and I can see where your radian values are here. For you to mark, 0, -4, pi over 2, 0, I can see that. The only reason I put that in there is I don't want people doing one of these. Here, I won't put any of these on there. I know it's 0 and I know it's 2 pi. I have no clue what's in the middle, so I'm just going to leave those blank and hope he doesn't notice. I'm going to notice, okay? But that's all I need there. Okay, but that's easy. That's kind of our kiddie pool. Okay, so we'll move along a little further. Our feet still touch, but that's about it. So here, this time, I do have a vertical shirt. Okay? No shirts, vertical shift. Okay? I do have one this time of up 1, so my center line would be at 1. Amplitude, I don't have any special value in front of my sign, so it'd just be 1. Okay. Period, no value in front of the x, so my period is still 2 pi. And I do have a phase shift this time of right pi over 4. So I start to think about this a little bit, and I'm like, okay, amplitude doesn't do anything, but this shift thing does. So let's give me an extra value in each of those spots. Never hurts to put too many lines. Now I see I have a phase shift this time. So normally here, with my period being 2 pi, I'd start at 0, I'd go to 2 pi. But I'm shifting right or adding pi over 4 to each of those. So 0 plus pi over 4 means I'm going to be starting at pi over 4. And I'm going to be going to 9 pi over 4. Now if you're going, wait a minute, where's 9 pi over 4 coming from? Reminder, if you think about 2 pi, but I want to turn 2 pi into fourths, which is what I'm doing here, since that's my denominator, I'd multiply by 4 to get here. I'm going to do the same thing to my numerator. So 2 pi becomes 8 pi over 4. And then I'm going to add one more to it. Whoo! 8 plus 1 is 9 pi over 4. Wow, we're even getting comic relief in on this one. Okay. So what that means to me is my 5 points are all going to be to the right of 0. So 0 is not going to be my first one. I know I'm starting at pi over 4. And I'm ending at 9 pi over 4. How do I get the stuff in the middle? Well, I have choices. There's actually a couple ways we spoke about, so I'll kind of give a little overview to both. One is finding the value in the middle. Now you're like, ooh, with fractions, I don't like this very much. Well, maybe we don't have to necessarily deal with that. Like, what do you mean? Well, if I take pi over 4 plus 9 pi over 4, that's 10 pi over 4, right? But I need to cut that in half. So, what's in the middle of 1 and 9? Well, 5 is. Okay, I'm kind of looking to see cut 10 over 4 in half. It's 5 over 4. What's in the middle of 1 and 5? Well, 1 plus 5 is 6. Cut that in half. It's 3. So I'm basically just finding averages. 5 plus 9 is 14. 14 divided by 2 is 7. Now, the other thing I'll mention here, especially now that we see what the angle measures are going to be, the other way I could have tackled this is what we did kind of up here before when we were first starting to calculate these before we'd have them memorized. We'd have looked at me and said, hey, they're going up by pi over 2 each time. So if I take pi over 4 and add pi over 2 to it, pi over 2 with a common denominator becomes 2 pi over 4. So basically what I find out is that's the magic pattern. Pi over 4, now add 2 pi over 4 to it. 3 pi over 4. Add another 2 pi. 5 pi over 4. 7 pi over 4. And I end where I know I'm supposed to. So either, halvesies or with the pattern, both can get me those radian values that I need. So once I have those, okay, phase shift taken care of. It also takes care of my period because I know where I'm going to start and stop. My amplitude is 1, so that makes me breathe easy. Okay, so the only thing I've got left is this up 1. So I'm like, okay, sine. Sine normally is 0, 1, 0, negative 1, 0. However, you're like, okay, I start at 0, but I got to do my up 1, okay? My vertical shift, my center line is always going to be the last thing I'm doing. Okay, start at 1, go up 1. Start at 0, go up 1. Start at negative 1, go up 1. Start at 0, go up 1. And the other thing that'll help me be confident that I did this right, whenever we're doing sine graphs, your first point typically is going to be on your center line. And this one is. Okay, when I'm doing cosine graphs, it's typically going to be the second point and the fourth one that are going to be there. So there's lots of these little clues that I can use to help me as I'm trying to get these things set up. So we'll add another little piece. Kind of keep these other in range here so we have them for a reference. Okay, cosine of 3x. No vertical shifts. Center line is going to be at 0. So if I want to get that in there, I can. Amplitude, nothing in front of my cosine. Nothing to think about there. Okay, period. This time we have a change, because I have a b value of 3. So my period is going to be 2 pi over 3, which in this case is nice, because as I keep going, I'm like, hey, there's nothing else here that I have to worry about. Why I put vertical shift in here twice, I couldn't tell you. At least it's better than shirt. So we're not going to worry about that, and there is no phase shift. So really the only change happening here is the period is getting squished. It's not shifting at all, though. So I know I'm going to be starting at 0, and I know I'm going to be ending with my period at 2 pi over 3. And now, similar to what we did up in number 2, I have options on how I want to come up with the rest of these. One way is to go, okay, what's between 0 and 2 pi? 1 pi. Now this gets a little more interesting. You're like, well, what's in between 1 and 0? 1/2 pi? Ha 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 ha. Kind of. If you think about it, if you go, okay, if I do 0 plus pi over 3, it's pi over 3. If I divide that by 2, oh, that's the same thing as multiplying it by 1/2. 1 pi over 6, 2 pi over 6, pi over 3, 3 pi over 6, pi over 2, 4 pi over 6, 2 pi over 3. Okay? That's one way I can handle it. And my other way that we've kind of talked about before, if I look at this and I go, hey, this is normally pi over 2. Pi over 2, I'm dividing by b. Dividing by 3, same as multiplying by 1/3. And I can get my first one and then just do the 2 pi over 3, 3 pi over 3, and I already have this one. So again, you've got options on how to get those values, but they need to be there. And once I have that, this is easy peasy because, well, there's nothing else that changes. Cosine starts at 1. Still got to know that. 0, -1, 0, 1. That's more what a cosine graph looks like. And again, my second and fourth points are going through my center line. So everything's checking off here. I'm feeling great. This quiz is going pretty good so far. So then we get, oh, now we're on the deep end. Okay. Everything's going to change this time. So I've really got to be cautious on how everything works here. I notice I'm going to have an up 1 vertical shift. So my center line is moving up to 1. I have an amplitude change this time of 3. That's going to have to be taken into consideration when I graph, besides that and the up 1. My period, I have a b value, pi. So 2 pi over pi is 2. So my initial period is 0 to 2. However, this time we're even going to throw one more twist in. I have a phase shift of left 2, which means each of these values are going to have 2 subtracted from them. You're like, Harty, really? Couldn't you have actually, and I'm going to like, watch me do some fun work. This is when the teacher messes up and you leave me a blank slate, what I can do with it. My y-axis is going to move over here, because I really don't feel like smashing my entire graph in there when I have this whole graph to work with. So I'm going to end at 0. And I'm going to be starting at -2. Now, if you really stop and think about that for a minute, this shouldn't be too difficult to come up with my other values. What's halfway between -2 and 0? -1. What's halfway between -1 and 0? -1/2. -1 over 2, -2 over 2, -3 over 2, -4 over 2, otherwise known as -2. All right. So we got that part knocked out. Now, remember, it's amplitude next, then vertical shift. So you're like, okay, 3, and then we're going to be like upping 1 and stuff. So So I start to look here a little bit, and I'm like, okay, sine graph normally goes 0, 1, 0, negative 1, 0. So when I start to do my points, I'm like, okay, normally I'd start at 0, but I have an amplitude of 3. So, whoops, 0 times 3 is still 0. Then I go up 1, which would put me on my center line, which would make me feel better. Okay. Normally here that I start at 1, amplitude multiplies it to 3, vertical shift bumps it another one up to 4. 0 is going to be on my center line. Negative 1 times 3 is negative 3. Up 1 gets me to negative 2. And 0 stays on my center line. So if you take your time and really think about what those values are and how they have effect, that's your biggie. But again, amplitude first, then shift. If you do them backwards, it's going to be messed up. Okay? But that's as bad as it gets. So not too terrible. Okay. So as we flip, okay, we get to have a little breathing room here for a minute. Let me zoom in a little bit. We'll see how patient the document camera is with me here. Okay, find the reference angle. Remember, nearest x-axis. And the other part, and you guys get to finish and be forever on YouTube. Oh, YouTube saying this. When you're doing reference angles, if it starts in radians, it ends in radians. That's what we're talking about. See, they do listen. So, when we're finding our reference angle, 360 is the closest. Just subtract them. Okay? Other thing with references, they're always positive. Okay? So here, ignore the fact that that's negative 120. Pretend it's 120. 180 minus 120 is 60. It's not negative 60. Okay? When I get over here, ooh, this is fun now. Now, if you need to think degree for a minute, it's okay. But again, to me, I look at this, and if I forget the pi for a minute, 2/3 is closest to 1. So 1 minus 2/3 is 1/3. If that drives you crazy, okay, other options would include saying, okay, so pi minus 2/3 pi. Ooh, I need a common denominator, which is 3 pi over 3. And I can get it that way. In your last desperate case scenario, I would not suggest this because you're going to forget to do it, put it back. You could sit here and go, okay, 2 pi over 3 is 120 degrees. 180, which means my reference is going to be 60. And then I turn it back into radians. But guess what? About almost all of you, if you do this, are going to leave it that way, and I'm going to be writing nasty stuff on your quiz. Okay? So let's try and avoid this idea and stick to one of the others. Negative 5 over 4. Eerily close to 1. So again, I look at that and I go, okay, negative 5/4, that's 4/4. Because again, just as a side, 5 pi over 4 minus 1 pi, 4 pi over 4. That's where this is coming from. Okay? Forget the negatives with this. It's going to drive you crazy. Drive me crazier. Okay. Convert degree into radian, radian into degree. If it's in degree, we want the pi there. We want the radians. Oh, here's going to come the challenge for some of you. This is going to be fun. Now remember, tomorrow, you will not have a calculator to do this with. Uh-oh. Yeah, we're going to have to use our brains for a minute here. This could be frightening for some of you. Now, some of you, it may come down to maybe you're going to use smaller numbers at the start. You're like, okay, I know 5 will go in and I'm doing some side work or I'm counting on my fingers or whatever it is I have to do. So I try 5 first, and then I'm starting to look at that and I'm like, wait a minute. 9 will still go into both of those. Okay, I got there. if you've got a little chunk piece, do that. Okay? And then here, oh boy, again, the things I put some of you through. Pi's are going to cancel. Now, one thing I could do here if I notice, 4 does go into 180. So if I wanted to try and reduce right away, which makes my numbers a little bit smaller, I could. But otherwise, the worst thing ever, I know, worst thing ever, if you've got to work to the side and do a little bit of old-fashioned, I'm going to work this out stuff, they're like, oh my gosh, what is he doing? It's this ancient technique called long division. Some of you may have heard of it. Or like I said, you could have canceled here and it becomes 45 and you do 7 times 45 and you're done. Don't care which, but you're going to have to use your brain one way or the other. So we'll leave that at that. Doing okay on time, so I'm not going to worry about skipping around here. I may not do every single one of these exact values, and actually I'm going to go to the bottom and work my way up, just so if we do end up time crunching, I don't want to time crunch and just totally miss sections. So let me come down here and work my way back up. Find the amplitude and period of each. Okay, amplitude is just going to be the value in front of your sine or cosine, unless it's a negative. Then remember, it's a distance, you make it positive. So all the ones here, that's pretty straightforward. That should be easy peasy points. Your period is not just your b value. Your period is 2 pi over b. So my period is 2 pi over 4. Don't leave it unsimplified, silly people. Okay, you don't have to come up with every single value in radians like you did before. Just the period. That's all I want. And for most of these, that will be pretty easy to come by. Now, will it always have some fancy thing to reduce? Not necessarily. Sometimes it'll just be that b value, and that's all I can do. So, don't spend all your time on the other stuff and then skip the easy points. Maybe you'll take on your quiz like I'm doing here and say, okay, here's all the easy stuff. Now I'll go back and do the trickier stuff here towards the end. Let's see here. State what quadrant you're in if tangent of x is positive and cosine is negative. All students take calculus. And you've got it on here too, on your cheat sheet. So if tangent is positive, one of these two, and cosine is negative, well, it's not this one then. Quadrant 3, not quadrant tangent. Okay, quadrant 1, 2, 3, 4. Find a value of x where this is true. Sine of x equals 1/2. Is there more than one solution? You're like, ooh. Well, let's see here. Value of x where the sine of x is 1/2. When all else fails, we're looking for sine to be 1/2. Okay, their sine is 1/2. Oh, their sine is 1/2. 30 degrees, 150 degrees. Is there more than one solution? Yes. 30 degrees and 150 degrees. Whee! Okay? So take advantage of the stuff that you have when you're going through there. It doesn't have to be bad, awful, and terrible. Now, speaking of last thing that doesn't have to be bad, awful, and terrible. Find the exact value of the trig functions. Sine of negative 135. Now, again, there are several ways you can take these on. One way you could do it, okay, negative 135. I could bust this out and go, okay, negative 135, negative 90, negative 135 gets me to here. Cosine, sine. That's the sine value. Negative square root of 2 over 2. Done. My other option would be to do like we had done before. I find a reference angle. My reference angle would be 45 degrees. The sine of 45 degrees is the square root of 2 over 2. But since it's negative 135, which would put me in the tangent quadrant, I know it's negative. They both work. It all depends on how you feel like tackling it. Now then the fun starts. Secant of negative 300. Okay, secant. Ooh, secant. What's that the inverse of? Cosine. So this is the inverse of cosine. So, what does that mean to us? Well, it depends on how we tackle it. If I want to, I could sit there and say, okay, cosine of negative 300 would be 60. Cosine, cosine. So the cosine of negative 300 we just got was a half. But I want the inverse. I want the flip of it. So the secant of negative 300 is 2. 1 over 2, flip it. Otherwise, I could use my reference angle for cosine, which would be 60. And then I'd be able to work that, because that would be 1/2. It's in quadrant 1, so it's positive, and I flip it. So that's why I'm saying we don't necessarily need to do every single one of these, because it's going to get kind of repetitive after a minute. So let's find something that looks like a little more fun. Ooh, a quadrantal. Ooh, a tangent quadrantal. That's even more fun. So I look, and I'm like, okay, 3 pi over 2 tangent of 270. So I start looking, and I'm feeling good about that until I look, and then I remind myself, oh, wait a minute. This is cosine and sine. They don't give me tangent on here. Uh-oh. What do I have to do to find tangent? Sine over cosine. So, sine over cosine. Negative 1 over 0, which is...
Undefined.
Thank you. Okay. 0 divided by something is 0. Division by 0 we can't do. You can't go up to somebody and say, hi, I'd like 0 slices of that pizza. It doesn't work. Well, I guess you could say if you weren't hungry, but that doesn't make much sense. Who isn't hungry for pizza? Okay. Let's throw another one of these twisters in. Cotangent of pi over 2. Okay. Fun times here. Cotangent of 45 degrees. Now the nice thing on this one, it's 45 degrees. You're like, why is that so nice? Remember, 45 degrees, cosine and sine are the exact same value. So, whether I take the tangent of 45, tangent of 45, which is square root of 2 over 2 divided by square root of 2 over 2. I wonder what that is. 1. Okay, cotangent. Oh, wait a minute. I just took the exact same thing and flipped it over. It's still 1. So I'm not being too obnoxious with these. Maybe a little obnoxious, but not a lot obnoxious. So I will do one more, because this is like how I like to roll. Tangent of negative pi over 3. Otherwise known as the tangent of negative 60. 2 options. We can either look at this from a reference angle point of view, or we could go, wait, negative 60. Okay, these guys. Cosine and sine. So tangent of negative 60 is the same as tangent of 300. So to get that, we would have the sine of 300 over the cosine of 300. Let's see if I can get this all on one screen. That'd be great. Here we go. So, sine of 300 is negative square root of 3 over 2, divided by cosine, which is a half. And I reminded myself, when I'm dividing by a fraction, I am multiplying by its reciprocal. The 2's will cancel. I have the negative square root of 3. The rest of the other, whopping 5 answers are on the key if you need them. But again, you kind of see, I mean, even with me gibbering right now, I'm at a little over 30 minutes. That unit circle shouldn't take you more than 6 or 7 at max. So you've got some flex here if you get stuck on some things. But you can't just stare and get done. So study it, go over it, be prepared. We'll do it then.